Okay, you guys, let's go ahead and take the time to do this review for our guide, except this time we're going to do confidence intervals with proportions. Okay, so in this one, we're going to say that Dax is out trying to do a study on the proportion of individuals in Casper who went hunting this season. He randomly selected 139 people from the community and had them report on whether or not they hunted this year. He decides to make a confidence interval to approximate the proportion of people hunting this season. He wants to have a 99% confidence level. Alright, so first things first, let's go ahead and look at our kind of breakdown of our test and what our sample and population are. So let's just start at the top. So the first one is that this is the list of the responses of the 139 individuals of whether or not they went hunting this season. That is our data. Next one, the proportion of the 139 individuals selected who responded that they went hunting. That is our statistic. That is the sample proportions. That would be E. Number 3, all people living in Casper is our population. We're trying to figure out the proportion of them who went hunting. So that is our, once again, population. So the 139 Casperites selected to respond to whether or not they went hunting, that is our sample. And whether or not a single respondent from the sample went hunting this season, that is our variable. That's kind of our question that we're asking. And then the proportion of people who went hunting in all of Casper is our parameter. So that's kind of the breakdown of how we look at these things. Remember, like the population is the big group that we want to make some conclusion about. The sample is some subset of that population. The parameter is like the truth about the population that we're trying to estimate. The statistic is the is like our point estimate of that population parameter that we got from our sample, and our data is just kind of the list of all the data that we collected, and the variable is like the specific question that we asked. All right, so at this point we said that, oh, it shouldn't be O'Shea, it should be Dax. But anyways, he knows that he can only use a normal approximation in certain circumstances. Is he good to proceed with calculations? Provide a short answer explaining why or why not. Okay, so we would say that we don't know what the original distribution actually is. It's actually probably like a Bernoulli distribution of just being yes or no's. But we know that we can use the central limit theorem if it's big enough. So it says, so since the number who responded yes and the number who responded no are both at least 15, the sample size is sufficient to invoke the central limit theorem. Let's see if that's true. Let's go ahead and grab this data. We want to copy it and let's paste it into our data set, or to be our data set. And we can click on view it and we have hunting this season, and let's just get a descriptive statistic for our active data set, and we've got 93 and 46. Those are both greater than 15, and so we know that we are good. And let's go ahead and take a second. We're going to change this O'Shea to be the right person, to be Dax. Okay, so now we've got to fix so that it's actually Dax. Notice that you can only use this normal approximation, and we were correct when we actually did this. Great. So the next thing that we need is we need the best point estimate of the true proportion of people who went hunting in Casper this year. So that would be our sample proportion. So what we could do, let's first see what our sample size is. So we know that our sample size is going to be the sum of the yeses and the nos. So we could just add these guys up, and we got 139. And if we want to know the proportion of people who went hunting, we would take the yeses, which would be this 46, and divide it by the 139. And that'd give us the proportion of people who went hunting in Casper from our sample, which is our point estimate. It's our best estimate of what the true population parameter is. Alright, so the next one down says provide the confidence interval for the proportion of hunters. Okay, so now we are approximating we're trying to find a range for pi. Okay, so let's kind of go back up here and let's take a look at our confidence interval equation. So we know that the confidence interval is just going to be simply this P plus or minus our margin of error. And our margin of error is going to be equal to Z, and we need to find this Z value at the alpha divided by 2 multiplied by the square root of what? P times P complement, and we want to divide that by n. That will give us our margin of error. So we just need to figure out what is our margin of error, figure out our z-score, and we can go from there. So if we figure out our alpha, that is going to be with our confidence level. So we know it's 1 minus the confidence level, so alpha is going to be 0.01. And now we've got basically the pieces that we need. We know what P is. We know that P is equal to this proportion. We know that P complement is equal to 1 minus this guy. And so let's figure out what our standard error is. So that's just going to be the square root of our P times P complement divided by our sample size of 139. And so we can grab this guy, toss it into our standard error. And now if we want our Z value, let's go into our commander and we can go to our random variables, continuous distributions, normal because we're using a Z distribution, and go to the quantiles. And the probabilities that we're going to put in here are our alpha divided by 2. And so we know that alpha was 0.01, so we've got 0.005 because it's divided by 2. And we can click OK. And here is our critical Z value. And if you notice, I only copied the absolute value of it because I'm only interested in like the distance from the mean right now. And so our margin of error is going to be this Z value multiplied by our standard error. And that gives me this guy for my margin of error. And so now I just need to do my p-value plus or minus my margin of error. So here's my p-value. I'm going to start off by minusing this guy. That takes me to my lower bound. I'll just drop it in here. And my upper bound is going to be this exact same thing, only plus. Plus or minus from our point estimate of our sample proportion. Okay, so we know that this is going to be two-tailed because up in our directions we weren't given any direction of which way we want our confidence interval to go. So if we aren't given a direction, we are going to be doing two-tailed. And if we do that, we can say that we are 99% confident that the true proportion of Casperites who went hunting this season is somewhere between 0.23 and 0.43, which if we look up, that is exactly what we got up there. Now what I will do is I will invite you to look at these other three and figure out why are those three wrong. If you need some help, you can go back to the video that talks about how we can interpret our confidence intervals and what are some pitfalls that we sometimes fall into. All right, next one down. Suppose instead we wanted the confidence interval for at least the true proportion of hunters. So this is a one-tailed, and we need to go to the left because we want to be 95% or not 95, we want to be 99% confident that it's at least some value, so some minimum value or higher. Okay, so if we want to do for the one-tailed, it is exactly the same, except one of them is going to be plus and one of them is going to be minus, and how we calculate our margin of error is a teeny tiny bit different. What we do is we just don't divide that alpha by 2. Besides that, it's like exactly the same. So let's go figure out our new z-score. So our new z that we are interested in is, let's go back to our normal quantiles, and let's multiply that guy by 2, which gives us our original alpha. And we can click OK, and this is our new z. And if you notice, the new z is just a little bit smaller than what we saw above. But now we are ready to figure out what is our margin of error. So our margin of error, what we're going to do is we're going to take our new z-score, and we're going to multiply it by our standard error that we calculated, which is right here, our standard error. And if we hit enter, we get this guy as our new margin of error. So this is our new margin of error. Now with our z and our margin of error, with our margin of error, we're ready to just calculate out our new confidence interval. And when we're wanting to say at least, we know that we want to go down a little bit. So we're going to do our p minus our new margin of error. So let's go grab our p. We know that this is our sample proportion. And we're going to paste it in. And we're going to say minus our new margin of error. And we can say that it's at least like 0.23. And we can say that it's all the way to infinity. That's going to be one-tailed. And we can say that we are 99% confident that the true proportion of Casparites who went hunting this season is at least 0.24. And we'll click on that guy. And now suppose we wanted to know that if we were doing a confidence interval for no more than the true proportion of hunters, we do the exact same thing, except instead of doing minus, we are going to do plus. And we put this on the upper end. And on the bottom, we put in a negative infinity. Or you can just type 2 O's for that infinity symbol. And once again, this is one-tailed. And we would say that we're 99% confident that the true proportion of Casparites who went hunting this season is no more than 0.42. Go look at why those other 3 are incorrect. Now, typically when we're looking for confidence intervals, we're just looking for one of these options, either upper one-tail, lower one-tail, or a two-tailed. But just for helping us practice, I had us look at all 3. Okay, so let's take a second and let's see how we did with our results. All right, if we look at the results, we actually have some errors in here. And it's specifically with what happens when we are dealing with proportions. So when we're dealing with proportions, we have to remember that proportions are limited, unlike means, to what their maximum and minimum values can be. The maximum proportion is 1, and the minimum proportion is 0. So we need to remember that when we are doing our one-tailed confidence intervals, that we use a 1 or a 0 based upon which direction that we are going. And if we look at that again, we now see that we have got the correct answers. So that's just important to know that when we are doing one-tailed, unlike when we're dealing with means, we can set the maximum at 1 and the minimum at 0 on those confidence intervals. Okay, so now I showed you how to do it kind of all by hand. Let me show you how we can simplify this whole thing, and we can do it with our software. So what we can do instead is we can go click on our basic statistics, and we can go to statistical inference, ask for a confidence interval, ask for a sample, and ask for a interval on the proportion. So what we can do is we can select on hunted this season, and we want the proportion to be of the people who said yes. And the confidence interval that we want is 99. And if we click OK, that's going to give us our confidence interval, our two-tailed. And if we look, we got matching answers right here, so we are good to go. Now, there is a way that we can make it give us our one-tailed proportions, but let's just go back and I'll show you how. So if we go to our intervals, What we can do is we still select on the hunted this season. We still select on the yes. The problem that we have is that it doesn't give us an option for the one tail. Well, what we can do is we can cheat. And what we do is we can double our alpha value. So if we double our alpha value, what it will give us both the upper and the lower answer for if we are doing a one tail upper bound or one tail lower bound confidence interval. So what I did, once again, I doubled the alpha. So instead of our confidence level of being 0.99 and our alpha of 0.01, I doubled alpha to being 0.02, and our confidence level is now 0.98. So I doubled that alpha. And if I click OK, look at our results. Let's see if we got the same thing. So when we calculated out our at least confidence level, or confidence interval, we had 0.238. Down here we have 0.238. That's great. And when we had calculated the no more confidence interval we got 0.4237, and we got 0.4237 here. So that's how you can kind of force our commander to do it for you. So now you've got some options of how you can do our confidence intervals for proportions. So good luck on this part of your guide.